Hey my dear viewers, welcome to this question. It says a bucket is 44 centimeter in diameter at the top and 24 centimeter in diameter at the bottom. Find its capacity in liters if it is 36 centimeter deep. So we follow up keenly. It's about a bucket. We have been given the diameter of the bucket at the top, and also at the bottom the diameter is 24 centimeter in diameter, so they are not the same. So you should have the notion that this bucket is in the form of a frustrum, and the question is we require to find the capacity in liters. I have been given the height of that particular bucket. So the bucket will be of this nature, such that the diameter is 44 centimeter. If the diameter is 44 centimeter, in other words, it means that its radius will be 22 centimeter. And at the bottom here, the diameter is 24 centimeter. Therefore, its radius at the bottom will be, small r will be, that is 24 divided by 2, that is 12 centimeter. So, if that is the case, therefore, and the other information that we have been given is the height. It is the height of this bucket, which is 36 centimeter. So we require to find its capacity. We require to find its capacity in liters if it is 36 centimeter deep. Therefore, since this is a frustrum, and frustrum is normally made from a cone, therefore we need to get the extended part of the cone, such that we are going to have a bigger cone and a smaller cone, and we find the difference in their capacity. So if we extend this, now this will be the cone from which the frustrum was made up to this particular point here, the vertex. So we already know this height, which is 36 centimeter, and we know the radius of the top, which is 22 centimeter. We also know the radius of the bottom, which is 12 centimeter, and therefore we can easily use similarities and enlargement to find the height. We find the height of the bigger cone, and then we work out the capacity. So allow me just to get an extract of this. Let me draw this line from top to the bottom, so such that this height of the smaller cone will be h. So the height of the bigger cone is 36 plus h. We also have the radius. We also have the radius of the smaller cone and the bigger cone. Therefore, using ratio for similarities and enlargement, that means the ratio, the radius of the bigger cone r divided by the radius of the smaller cone, that ratio will be equal to the height of the bigger cone over height of the smaller cone. And since here we know the radius of the bigger cone is 22 over the radius of the smaller cone is 12 centimeter, this will be equal to height of the bigger cone is 36 plus h. 36 plus h. Height of the smaller cone, this is the smaller cone here, that is h. So cross multiply, we have 22h is equal to Then you have 12 times 36, that is 432, plus 12 times h, that is 12h. So this will be 22h minus 12h is equal to 432. Therefore, 22h minus 12h, that is 10h, is equal to 432. Therefore, h is, divide both sides by 10, we get 43.2 centimeter. So the height of the smaller cone is 43.2 centimeter. So, and that is actually information that we need. Now to get the volume, of the frustrum or the bucket, it is volume of bigger cone, we subtract the volume of the smaller cone, and the volume formula for finding volume of a cone is given by a third pi. For bigger cone, it will be capital R squared multiplied by capital H, minus the volume of the smaller cone will be a third pi times small r squared times small h. So I hope that is okay. Now, what we actually need here, we know that pi is 22/7, and therefore capital R has bigger radius, so that is 22 centimeter, small r is 12 centimeter, small h is 43.2 centimeter, and capital H, which is the height of the bigger cone, that is 36 plus 43.2, which we get 79.2 centimeter. So these values is what we are going to use in our formula here. So volume of the bigger cone, so this will be a third times 22/7 times r is 22, we square it, times h is 79.2. So we work this out. Then the next one is height of volume of the smaller cone, which will be a third times 22/7. Small r is 12, so times 12 squared, then times height of the smaller cone, which is 43.2. So if we work it out, the first part, we end up getting 40,158.17 minus the volume of the smaller cone. Using a calculator, we get 6,517.03, and this will be centimeter cube. So if we subtract, we end up getting 33,641.14 centimeter cube. But the question requires we find the capacity in liters, and capacity 1 liter is equivalent to 1,000 centimeter cube, and therefore the volume that we have, we divide it by 1,000, so that will be 33,641.14. we divide by 10,000, 1,000. So if we divide by 1,000, we shall end up getting 33.6414 liters. So this is actually approximately to a whole number. It will be 34 liters, and this is the capacity of the bucket in liters.